Namaste to everyone. I welcome you all in my YouTube video channel. Today I will deliver lecture on graph theory, lecture number 31, in which I will discuss the fundamental cut sets referred to a spanning tree. When we speak about fundamental cut sets, we speak about a spanning tree of a graph. Let T be a spanning tree of a connected graph G. Spanning tree T is a tree. Let this is a tree V1, V2, V3, V4, V5, V6 be its vertices. If we remove one edge from this tree, the resulting graph is a disconnected graph. Here we see that in one set vertices are V1, V2, V3, and in other set vertices are V4, V5, V6. In a similar manner, if we remove a branch B of the spanning tree T from the spanning tree T, we get two disconnected graph. Since the spanning tree T contains all the vertices of the graph G, and here we have removed one edge from the spanning tree, so no vertex will be removed. By removing the branch B, the spanning tree will be converted into two set of disjoint vertices. First set will contain capital V1 set of vertices, and second set of vertices be V2. All these vertices V1 and V2 are disjoint. This V1 set be the set of all vertices of the first component, and capital V2 be the set of all vertices of the second component. And this V1 intersect V2 equal to phi, and V1 union V2 equal to set of all vertices of G, of graph G. That is set of all vertices of the spanning tree T. If we take a minimal set S, which will include a single branch, of spanning tree T, and if it will contain some chords referred to spanning tree T, such that G minus S is a disconnected graph such that set of all vertices of first component be capital V1 and set of all vertices of second component be capital V2. Therefore, this S, the minimal set S, will contain a single branch of the spanning tree T. Also, it will contain some chords, so that removing all the edges of S from graph G, G minus S will be a disconnected graph in which V1 be the collection of all vertices of the first component and capital V2 be the collection of all vertices of the second component. Then S is called a fundamental cut set referred to the spanning tree T. Therefore, each branch B belongs to spanning tree T with some chords. This set S will be a cut set, and this cut set be the fundamental cut set referred to the spanning tree T. Therefore, number of fundamental cut sets referred to spanning tree T will be number of branches in the spanning tree T. Let N equal to number of vertices in G, and this will be number of vertices in spanning tree T. Therefore, number of edges of T equal to N minus 1, that is number of branches of spanning tree T equal to N minus 1 implies that number of fundamental cut sets equal to N minus 1 referred to this spanning tree T. Now we define the fundamental cut sets. Let T be a spanning tree of a connected graph G. A cut set S of G which contains exactly one branch of T is called a fundamental cut set of connected graph G with respect to spanning tree T. By an example, we will clear our concept. Let this is a connected graph G. Here we have vertices V1, V2, V3, V4, V5, V6 and edges are A, B, C, D, E, F, G, H, I, J. Let for this graph G we have a spanning tree T. This is the spanning tree T. Here we have vertices V1, V2, V3, V4, V5, V6 same as vertices of graph G. But some edges of G, graph G are not present in the spanning tree T. All those edges which are present in spanning tree T are called branches of the spanning tree T. We know that when a branch is removed from a spanning tree T, it will disconnect the graph, that is spanning tree T, into disjoint graphs. From the definition of fundamental cut set, we know that a fundamental cut set S contains exactly one branch of a spanning tree T. Here, corresponding to each branch of the spanning tree T, we will get a fundamental cut set. Here we see that A be a branch of the spanning tree T. Therefore, fundamental cut set determined by branch A. Here A be the branch of the spanning tree T and B is not a branch, B is a chord. So we take the fundamental cut set like this: AB. AB set containing elements A and B. Now C be a branch of the spanning tree T. So fundamental cut set determined by branch C. Here C be the branch and D, E, B are not branches. D, E, B are chords. So we may take, this is the fundamental cut set containing D, E, C and B. Third, here F be a branch of the spanning tree T. Here F be a branch and D, E, G are not branches, they are chords. So we may take fundamental cut set determined by branch F. Here F, so here D, F, E, G. D, F, E, G. Here J be a branch of the spanning tree T and Here H is not a branch, E is not a branch, and G is also not a branch. So we may take this is the fundamental cut set containing fundamental cut set determined by branch J H E G. Now I be a branch of the spanning tree T. So fundamental cut set determined by branch I be the branch, J is also branch, so we may not take cut set like this. Here I be a branch, H is not a branch, E is not a branch, G is not a branch. So we take this type of fundamental cut set. I, then H, then E, then G. Here number of branches be 1, 2, 3, 4, 5. So we get 5 number of fundamental cut sets. 1, 2, 3, 4, 5. Now we prove a theorem. Theorem is for a given spanning tree T of a connected graph G, a chord small ci that determines a fundamental circuit capital C occurs in every fundamental cut set associated with the branches of capital C circuit and in no other. Now we prove this. Firstly, we want to know what is fundamental circuit. See, by a particular example, we want to be clear about the fundamental circuit here. Let T be a spanning tree. Let this is a spanning tree T for a given graph G. Here V1, V2, V3, V4, V5, V6 and V7 be the vertices of the spanning tree T. Here branches are A, B, C, D, E, F. These are the branches of the spanning tree T. If we add one chord, here we add one chord in the corresponding place. Here we get a circuit. Here circuit B is B, D, E, G, and this type of circuit is called a fundamental circuit. Means if one chord is added to the spanning tree T, it forms a circuit, and that circuit is called a fundamental circuit. Here branches of the circuit will be B, D, E, G. Now we start our proof. Let T be a spanning tree of a connected graph G. Let small ci be a chord which is included with spanning tree T such that it will form a fundamental circuit C, capital C. Capital C will contain chord Ci. Other than this, it contains some branches B1, B2, Bk. Let this is number 1. Let S1 be the fundamental cut set determined by the branch B1. Let this will contain branch B1. Since fundamental cut set will contain exactly one branch of the spanning tree T and other edges are chords, some chords. Let chords are C1, C2, comma, comma, dot, dot, CP. Let this is number 2. Here it is clear that B1 belongs to C, circuit C, fundamental circuit C. Also, B1 belongs to S1, implies that B1 belongs to C intersect S1. We know that the circuit and cut set will contain even number of edges in common. Here one edge B1 is the common edge. Therefore, remaining here chords, these are chords, and here Ci be the chord. So Ci will be one of the C1, C2, Cp. Therefore, Ci must be one of C1, C2, Cp. Therefore, Ci belongs to S1. So, this chord Ci must belong to the fundamental cut set associated with branch B1. Therefore, Ci must belong to fundamental cut set associate with B1. Let S2 be the fundamental cut set determined by the branch here B2. Therefore, in the similar manner, we may show that Ci chord Ci must belong to S2. Let capital Sk plus 1 be a fundamental cut set determined by branch small b k plus 1. It is clear that branch bk plus 1 does not belong to circuit C. Therefore, if small ci chord belongs to fundamental cut set S k plus 1, we may not get that the even number of edges in common to S k plus 1 and C. Let chord Ci belongs to fundamental cut set Sk plus 1, but we get that the branch bk plus 1, which determines the fundamental cut set, does not belong to circuit C. Therefore, we get that the chord small ci belong to every fundamental cut sets determined by branches B1, B2, Bk. Proved. Now we prove the next theorem. Next theorem is, for a given spanning tree T of a connected graph G, a branch Bi that determines a fundamental cut set S is contained in every fundamental circuits associated with the chords in S and in no other. Now we prove this. Let T be a spanning tree of a connected graph G. Here Bi determines a fundamental cut set S. Since we know that each branch of the spanning tree determines a fundamental cut set. Let the fundamental cut set determined by the branch Bi equal to S. Therefore, S will contain a single branch Bi and other chords. Let C1, C2, dot 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 Ck. C1, C2, dot dot Ck are chords. Let this is number 1. Let C1 be a fundamental circuit determined by chord small c1. This is capital C1. This is small c1. Therefore, circuit capital C1 will contain chord small c1 and some branches B1, B2, dot 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 BP. Let this is number 2. Here we see that C1 belong to S intersect capital C1. Capital C1 be the circuit, fundamental circuit. This is number 3. Since we know that the cut set and the circuit will contain even number of edges in common. Here one edge C1 belongs to S intersect C1. Therefore, we will get that here we have Bi. Bi be one of B1, B2, B dot 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 BP. Therefore, Bi be one of B1, B2, BP. Therefore, C1 and Bi belong to S intersect C1. That is, Bi will belong to C1 circuit, fundamental circuit determined by small c1 chord. Let capital C2 be another fundamental circuit determined by chord C2. Similar to above, we may show that Bi belongs to C2. Let capital C K plus 1 be a fundamental circuit determined by chord small c K plus 1. Since chord C K plus 1 does not belong to S, if a BI branch belongs to circuit CK plus 1, then there will be no even number of edges in common with S and C K plus 1. Therefore, BI may not belong to C K plus 1. Hence, BI belongs to the circuits determined by chords C1, C2, CK. Proved. Thanks for watching my video. If you are satisfied with my presentation and contents, then please click on like button and do subscribe my YouTube channel. Thank you.